Hey, welcome back everyone. I am here today to do a request for a calculation involving frequency. So let's go ahead and get started. Alright, the first thing that I did was reword the question because I didn't know where the question came from. So anyway, this is basically what they're asking us to do. Johnny wants to calculate the frequency of a particular type of radiation in units of hertz. Now Johnny is told that the wavelength is basically 4 times 10 to the second nanometers. What's the frequency of this radiation? So let's go ahead and get started. Now, the individual told me that they wanted us to use the speed of light value of C equals 2.998 times 10 to the 8th. Now, that's meters per second. Now, in my class, I always just tell my students, let's just go ahead and use 3.0 times 10 to the 8th meters per second. So, if that's different than what you've been told, then that's fine. But that's usually what I tell my students to use because 2.998, that's close enough to 3. So anyway, there's the speed of light. And let's go ahead and get started. So in order for us to calculate the frequency, we need the speed of light equation. So let's go ahead and write that down. Now the speed of light is C equals lambda times V. Now some textbooks will show F for frequency, but let me go ahead and make sure you understand what these are. C, of course, is the speed of light. Okay, we'll write that down here. Speed of light. And lambda, which is a funny looking type of wavy X, is a Greek letter, and basically all that it is going to stand for here is wavelength. And V, of course, is frequency. And that's what we're going to be concentrating on, is this one. We want V. Okay, so let's go ahead and write down this equation. We have C equals lambda times V. Now we're going to focus all of our efforts on solving for V. Alright, so if we do some algebra, we need to get V by itself. Now if you notice, C is already on the other side. Sorry, C is already on the other side. Yeah, I know I'm congested, I'm a little sick. Anyway, C is already on the other side, so we don't have to do anything to C. We don't have to touch it. But we do need to get rid of lambda, so this wavelength. To get rid of this wavelength, notice that it reads wavelength times V. We need to divide both sides by lambda. What that will do is cancel lambda over here with the V, but it will put the lambda underneath C. So that's what we're doing. Now some people, they may not see this. They may just think of it as, well, I'm just going to move this down here. That's fine. If you do it that way visually, that's fine. There's nothing wrong with that. Now what we need to do now is we need to plug in our known values and our constants into this equation since we're solving for V. Okay, so here we go. Speed of light is 2.998 times 10 to the 8th meters per second divided by wavelength, and the wavelength is this 4.4 times 10 to the second nanometers. Okay, now we would be ready to just go ahead and type this into the calculator, but we kind of got a problem right now. Right now our units are not matching. Notice that this is meters, this is seconds, but down here this is nanometers. So the meters itself has a prefix on it. Now we need to make sure that we know that nano, let me write this over here. We'll write it over here. Nano is a prefix on the SI system. We need to know that the prefix nano, which is a little bitty n, stands for 10 to the negative 9th. Now what we're going to do is we're going to change that here. Now we could off to the side do another calculation and change it and everything, but I'm going to show you how I do this. Okay, so this is what I do. Alright, so we've got V equals this 2.998 times 10 to the 8th meters per second divided by, notice nothing's changed so far, 4.4 times 10 to the second. Now, on this nano, this is when I change it. I'll go ahead and write down times 10 again. But this time, I'm going to put -9 here. And then I will write the meters here. Now, granted, this does make extra work, but I do this so I can see that I took care of the nano. So then, what I will do is I will combine those like bases. So V equals 2.998 times 10 to the 8th meters per second, divided by 4.4 times 10. Now, what we need to do is we need to collect these like bases. Now, when you're trying to combine bases that match, you add them if they're on the same numerator or the same denominator. Notice here that they're in the same denominator, so we're just going to add them together. So basically what we have is we have this 10, which is to a -2, times 10, which is to a positive 2. A positive 2, and we have this other 10 that's to a -9. Now what's going to happen is we're going to keep the 10, but we're going to add these two together. A positive 2 plus a -9. Now if you notice, that'll give us a -7. So we're going to write a -7 right here. Alright, so we now have meters. Now we can type this into the calculator, because our bases now, our units now match. Notice that this is meters per second, and this is just meters. So they match, meaning, they're the same. So not really the units themselves, but all the little sub parts of the units match. Meters and meters, seconds. I know we don't have seconds here, but that's okay. But we do need the seconds to stay. But that is good because now we can clearly cancel out our meters. Alright, so let's go ahead and type this into the handy dandy calculator. So we'll pull up our calculator. I have a TI-84. So let's go ahead and turn that on. Let's clear this out. And now we're going to type this in. Now I'm going to show you how I have my students to type this in on the 84. Alright, so once you get it turned on, let's punch it in. 2.998. Now, to do scientific notation on this calculator, please hit second and the button above the 7. What that does is that ignores the comma and it takes over the function that's written in blue here, which is EE. Alright, so there's that. Now we're going to type in 8. And all that little e that's shrunken down, that's capitalized, all that stands for is times 10 raised to some power. I always type mine in that way. Okay, divided by 4.4 times 10, so we hit second, the button above the 7, and then, which is the exponential form, which is now we need to type in -7, so we type in -7. And then, lo and behold, there is our answer. So let's write all that down. Wow. I don't know if I can remember all that, but let's see. 6.8. I don't remember it. Sorry, hit the mic. 6.81364. Oh, well, it wasn't 4. 8163. Yeah, I was probably rounding. Didn't mean to. So let me erase that 4. So once again, let's see. I'm horrible at remembering these, so just forgive me. 6.8136. Looks like 3 6 repeating. 3 6 3 6 3 6 4 times 10. Now you're probably saying, why'd you write times 10 for? Well, because that's E14. So that's E14. And basically these look like they were repeating all the way through until they got here. So let me make sure I didn't write too many 36s. 1, 2, 3, 4. 1, 2, 3. I did. I wrote one too many. But anyway, forgive me for that. But anyway, sig fig wise, I only have 2 sig figs because the constant it has 4, but when you're trying to determine the number of sig figs, you don't go by the constant, okay? You go by the number that was in, or the set of numbers that was in the question. We only have 4.4 here. That's only 2 sig figs. So our main 2 numbers are these 2 that are in the front. Now these 2 that are in the front, if you look to the right, there's no way for 6.8 to round to 6.9. So it's going to stay at 6.8. But we will still retain the times 10 to the 14th. So let's write that down. So V equals 6.8 times 10 to the 14th. Now, what we do need to do is make sure that we record the correct units. Now, if you look up here, meters and meters are canceled out. The only thing that's left in the numerator is /s. That /s is 1 over a second. Now, 1 over a second is the same thing as basically in this 1 cycle per second. So basically that's our hertz, our Hz. Okay, so anyway, guys, I hope that this video was helpful. If it is, great. If it's not, then you can always message me, and if I have time, I will try to work one of your requests. So, all right, guys, other than that, y'all have a good one, and I will see y'all tomorrow, or the next time I do a video. All right, guys.